Just a little bit about me, a little bit of background first of all. My name is Teitelbaum. I'm currently with Clear Channel. I'm the Director of Database Operations. I've been with them for about 5.5 years now. I've been working with PHP and MySQL for about 10 years. Programming probably for maybe since 95 or so. So I've been doing some of this for a little bit of a while. We're going to talk a little bit about database abstraction layers. A lot of this is stuff that I've picked up along the way. See if this works. It worked before, so of course it's not going to work now. That's okay. I'll do it manually. It was a little delayed. Okay. So some of the things I'm going to talk about is just a little bit of background on database abstraction layers. A little bit about security. I'm going to talk about caching, scaling reads, and logging and error handling. So, as I dive into this, I just want to mention that the stuff that I'm talking about is not an absolute guide to abstraction layers. I'm not saying everything I'm going to tell you about, if you have an abstraction layer, you've got to put all this stuff in it. That's definitely not the case. View this more as an a la carte menu of things that you may want. Some of these are solutions to certain problems. If you have one of those problems, great. If you don't worry about it. There's a lot of discussion on abstraction layers, pros and cons, need one, don't need one. A lot of people talk about extra overhead they create. There are lots of abstraction layers out there. I have not kept up to date on all of them. So to dive right in and start talking about what is an abstraction layer. Basically, it's nothing more than a middleware layer between your application and your database. Like in its simplest form, that's it. Don't worry about any extra functionality, anything else that it's doing. Now, in computing, we have a tendency to abstract resources. We do with memory, virtual memory, disk, LVM. So having a layer of abstraction around a database is really not that uncommon when you view it as a resource compared to everything else that we do. Now, having a central database abstraction layer gives you great flexibility and control because it's basically a unified conduit where all of your database activity passes through. Another thing that's really important to mention is that the concepts that we're talking about are really universal. So although we're talking specifically about PHP and MySQL, these can be applied to pretty much any other language and other databases as well. Now, database abstraction layers don't have to be heavy. That's often one of the greatest arguments against database abstraction layers. Hey, we've got a lot of extra processing power that's going to be required to handle this. It's going to be a burden on the application. But that's not always true. In many cases it may be, but it doesn't have to be. So, what I want to do is, I'm going to show you literally what I'm calling the world's simplest abstraction layer. And this is it. That is an abstraction layer. There's not much to it. Written in PHP, literally just taking the MySQL class and extending it. It's not doing anything else. We're not adding any extra functionality. It is doing nothing more than extending it, but giving you the ability to overload and extend this later if you needed to. And I'll give you an example of what that might look like. Literally, same thing. At some point in time, you need to add some functionality, so every time a query is executed, you want to do something else. So that's what that comment is. Right over here, do something extra. Whatever it is you might want it to do, execute a second query, write to a log file, whatever the case may be. We're overloading the query, and now this is where the power of an abstraction layer is starting to come into play. So the first thing that I wanted to talk about, diving into this, and probably the least critical, is security. Now, where this comes into play is filtering. You can actually use your abstraction layer to pick up on and detect queries that are passing through, and you may choose to filter them and reject them. And I'll give you an example of a case where I actually used this. It was an application, there was a lot of people working on it, some of the data models were pretty old, and one of the developers was having a big problem on some of the queries that he was working on. He couldn't get these things optimized anymore. And what was actually happening is MySQL was rejecting the query. It wouldn't even run it. It was throwing it away, and the reason why it was throwing it away is under the hood what was happening, it was generating a Cartesian product, and then it was filtering down the records. So MySQL said, no, I'm not doing it. And this guy was trying to find a way to make his query work, And he actually did, to his credit, he found a solution, and the way he did that in MySQL was setting big selects to true. And basically what that does, it tells MySQL, hey, I'm about to do something really, really bad, but it's okay, let me do it anyway. So, not really the greatest thing. So what we did is, we put something into the application to make sure that nobody could do that. And it wasn't for that one specific instance. On a broader sense, in MySQL, you have your session variables and you also have your global server variables. And when you create a new database connection, your session variables inherit from the global server variables. So there's a little bit of a problem if you can go and start changing all of these things. If your application can connect to the database and do whatever it wants and start changing all of your session variables away from what the server is set to, basically it defeats the purpose of ever having set those that way in the first place. So that's an example where filtering comes into play and can be valuable. I did it with a set statement, but you can use it on anything. Another thing that you could do if you needed to is deal with SQL injection. Not really the best place to do this, but if you're in a bind and you have no choice, it's better than nothing. So one of the things that I've found is some of the worst SQL injection that I've seen is in legacy applications that are old, very old, been inherited, and when they were originally written, they didn't do a very good job of sanitizing the input. So they're vulnerable to SQL injections. And one of the biggest SQL injection attacks that I'm experienced with and have had happen often are basically DOS attacks, where you see a lot of things coming in the query string using something like the sweep function in MySQL. And what that does is it's a DOS attack because all these connections are coming in, and in turn that creates a database connection. And it's using the sleep statement, somehow throwing a very high number in there. The idea behind it is, I want to take that database connection and I want to extend it. I want to make it live for a very long time. And as more and more connections come in, continuing to do this, what happens is the number of available database connections is going to dwindle because they're all going to get used up. Eventually you're going to hit MaxCon, and now you've got a resource starvation problem, and you've got an outage. So if you have a situation like this, and all of a sudden it's uncovered, you're better off putting a web application firewall in place. But if you need to buy yourself some time, and all of your database queries are funneling through your abstraction layer, you can use this to buy all the time. Here's a little bit of an example. I was talking about the set statement. So literally, this is it. Query comes in, run a regex on it. What's going on? Is it a set statement? It is. Throw an exception. That's the end of it. So again, you don't even have to throw an exception if you wanted to. You can allow the query to pass through, write to a log. There's a lot of other things that you can do. So one of the things I wanted to talk about with abstraction layers is scaling reads. So before we really dive too much into how you might do this, let me first kind of go over a typical architecture, typical topology, master and slave. So when we try to scale reads and writes, really what we're trying to do is we're trying to scale the reads. We want to send the writes to the master, and we want to send our reads to slave databases, read-only slaves. So generally, we've got a bunch of web servers. They're sending the writes up to the masters, their DML, the inserts, updates, deletes, and they're sending all of their reads down to slaves, which are probably load balanced behind a VIP. So this is a somewhat extremely generic topology. And of course, ignoring any means of high availability or whatnot, we're kind of stripping any of that stuff out of here. So the idea again is we want to separate the reads and writes to fix a problem where we had a lot of reads going to a master in a legacy application. And the volume of reads was very high. So I was looking at MySQL Proxy as a way of basically putting that in between the application and the database to intercept all those reads and redirect them to the slaves. Well, one of the problems that I found with MySQL Proxy, based on the research that I did and several conversations that I had with people from Oracle, is that it just couldn't handle the volume. There's too much traffic that's passing through it. Not to mention another downside might be you're actually changing your architecture. Here's one more component that you're kind of mixing into the stack, one more thing to fail. So if all of your queries that hit your database pass through your central abstraction layer, there's no need to throw something else. You could actually have the abstraction layer do that work for you and redirect your reads over to your slaves. So again, the basic concept is we want to take the slaves, we want to take the select statements, and we want to redirect those to the slaves, and we want to allow everything else to flow up to the master. So we would do this using a regex inside the abstraction layer. Every time a query comes in, it could analyze the query and basically say, hey, well, what is this? Is this a select? If it's a select, we're sending it down to the slaves. If it's not a select, anything else, we're going up to the master. So this really, where this comes in and becomes extremely valuable, again, is if you have an older application and it didn't split your reads and writes, and it's taking a lot more traffic, or if it's an application that you developed, and again, now you need to scale and it wasn't built out that way. Rather than going and rewriting the entire application, you could literally go to your database abstraction layer, modify, and drop some of this stuff in place, and this will do the work for you, and now you're splitting your reads and writes for your entire application, and you never even had to rewrite the whole thing.
Or your abstraction layer can have different methods for like select or...
So another use case for this, and this is one that was very valuable for me, is when you're working with a legacy application where many components of it have been retrofitted to actually send their reads to a slave, but there's still a lot that hasn't. Everything passing through the abstraction layer, easy to catch all that stuff and clean it all up. Now, let's just say that you didn't actually want to redirect. Let's say you didn't like the idea of that. I don't want my database abstraction layer going through and actually doing all this work under the hood. Well, instead of actually doing the redirecting, you could have the abstraction layer just log it. Basically say, well, here's a query that's hitting the master, probably shouldn't be, throw it in a log file. You can go back later on and actually review this and make a decision on what do you want to do with it. Do you want to let it hit the master? Do you want to fix it, find it in your code, and actually correct the whole thing? So another thing, kind of moving away from your reads and writes, another thing that I wanted to talk about is what I would call load balancing on a budget that you can handle with your abstraction layer. Not really the ideal way to do it, but if you're in a bind, you can use it to buy yourself time. So basically, load balancing on a budget, I'm calling it load balancing, but it's really not, because load balancing implies you're balancing the load across multiple hosts. If you do it in your abstraction layer, you're really not load balancing anything. A couple things to mention is, if you do this in the abstraction layer, you don't want to use a loop. The idea is you've got multiple hosts. Remember the diagram that we just had. We have multiple slave servers, and we want to try to distribute the connections across them. Well, ideally, you want to have a load balancer or something in front of it to do that for you, but if you have to scale really quickly, there's a budget issue, whatever the case may be, this could be an option. Now, you wouldn't want to use something like a loop, because if you think about this, if you had like a for loop, and you're looping through all of your database slaves, what's actually happening is the very first database slave in your list is always the one it's going to try to connect to. So if you looked at the traffic across all your slave servers, one of them is going to have all the traffic, and the other ones aren't going to be doing anything. So you don't really want to use a loop. Round robin is going to be very difficult to implement because you need some means of persistent information to know what the last host was. So every time your application, every time the process is executed and your abstraction layer tries to pick a host, it would have to record that somewhere so that the next time it runs, it knows, move on to the next one. So again, it's sort of like reinventing the wheel. At this point, you're better off with an abstraction layer. You're better off with a load balancer. Now, again, I said it's not real load balancing, and the other big problem with this is if you randomize and you pick a slave at random, there's no way for your application to know whether or not one has failed. So a load balancer will be doing things like health checks. Every so many seconds it will connect to each one of your slaves, and it will determine the health of the slave, and if the slave is healthy, able to accept connections, stays in the pool, everything is good. If it's unhealthy, something's wrong, the service crashed, whatever the case may be, it's going to yank it out of the pool, and that machine will no longer be taking on connections. So if you're trying to do load balancing in the application through the abstraction layer, you could run into that problem. If you have a slave that fails, the application doesn't know about it. Of course, there are some ways you could probably try to get around this. You could set up something like a cron job that does a health check every so often and writes the health of the machines into a file, and on every execution, your abstraction layer parses that file and tries to figure out which hosts are healthy. So that would be one way of getting around it. So I've got a couple diagrams to show some of this as a flowchart here. So redirecting selects, we just talked about this. Basically, this is really all that would happen. You'd have your query method inside your abstraction layer, and every time you execute a query, it's literally nothing more than an if statement and a regex. It just looks, hey, is this a select statement? If it is not a select statement, because that's the easier one first, not a select, okay, do exactly what we're supposed to, execute the query on the master, and that's the end of it. Don't worry about it anymore. If it turns out that the query is a select statement, we could then open up a new database connection to the slaves. In this case, if we had a slave, if we had a load balancer, open up a connection to the slaves, execute your query on the slave, and return afterwards. The great thing about this is all those dirty details are tucked away inside the abstraction layer, and the rest of the application has absolutely no idea this is going on. You could literally write a query, you can execute an insert statement and a select statement, and you think you're using the same database connection for both of them, but in fact your abstraction layer is splitting the two and sending them to different places. So again, you may be thinking, well, you like that, but you don't want your abstraction layer actually doing this work for you. So if that's the case, maybe you just want to log them. Maybe what you want to do is every time you execute a query, maybe you want to do two things. Check to make sure that's a select, and to make sure that you're connected to the master. This may be valuable in a situation, like I mentioned, where an application is directing many of its reads, many of the select statements over to slaves, but not all of them. A lot of them somehow still hit the master. So this sort of logic might be valuable because if you are connecting to both a slave database and a master database, you don't want to try to redirect your select statements when they're already going to your slaves in the first place. So you would want to check to make sure both are we connecting to the master and it's a select. So in this case, we're saying, hey, you like the idea, but you'd rather not the abstraction layer do the work for you. You'd rather let it create a report, and then you have to go through and actually modify all of those manually. In that case, it's still pretty easy to do. Instead of reconnecting to the slaves, just log the query in a log file, execute the query like you normally would, and that's the end of it. So the next up is load balancing, like I was just talking about, the load balancing on a budget, as I'm calling it. I find it's easier to actually show this with a little bit of source code than it would be to show it in a diagram. Literally, again, all we would be doing is just overloading the parent. Now, in this example, let's just say that you had one database slave, right? We're not saying that you want to go from no slaves and split them in this example. We're pretending you have one slave, but now for whatever reason, you need to add a second, you don't have a load balancer, it may take 2 weeks before you can get one in, you got to do something quick. So literally, all we would do is, every time we try to connect to the database, just check, hey, are we connecting to the slave? If we are, then all we're going to do is we have a list of available slaves, pick one of them at random, and connect to it. That's pretty much it. Again, all the issues that I said, we don't know which slave is available. In this case, number one could have died, the power supply could have failed, something like that, if it's a physical server, and the application is going to have no way of knowing that. So this does have its caveats. Moving on off of trying to scale reads, I want to talk a little bit about caching. So a couple things on caching is MySQL has a query cache that's built right in. Now, the query cache is generally not the most efficient for several reasons. One of the reasons is there is a single mutex that's on that query cache. Now, if you're trying to retrieve results from the query cache, write them into the query cache, or even check to see if your query is cached, you're going to be blocking, right? If you've got a lot of concurrency, this could become a little bit of an issue for you. Another thing with the query cache is results will expire if there are changes to any of the tables that are joined. So for example, if you have a query that's joining 5 different tables together, even if the result set would not change, if you make any changes to any of those 5 underlying tables, the result set is now going to be basically expired and kicked out of the cache because it doesn't know what's changed, so it's evicted. So again, that becomes a problem. If you have multiple slave servers and you're load balancing, the query cache is actually not shared across all the different database slaves. So if you've got a query that gets executed very frequently, it's going to have to execute on every single slave. Again, the other problems that we just said with the query cache aside, all the different slaves have to do the same thing. Now, another thing, I'll give you an example of a situation where the query cache becomes really inefficient. And this is the type of table that I've had to work with. Often we have, in radio, we have a table that basically records every song and every commercial that every one of our radio stations is playing across the country. So, a lot of data, and the big thing is a lot of data very, very often and very quickly. So that table gets about 25 inserts per second. So when you think about this, if you try to query the table, when the database is going to take the results and shove it into cache, it's actually more work than it's worth to try to cache it. So it'll be more efficient by not caching that at all. Another thing about the query cache is you may not even need real-time data. Depending upon what the query is that you're trying to execute, it may be okay if the data is stale. It may not be a big deal. So if it's user activity and user history, you may want it up to date. If it's counting how many comments have been on an article, you may not need it to be up to date every single moment somebody loads that page. It may be okay if that's only accurate within 30 seconds, a minute, 10 minutes, something like that. So a little bit more on caching. What really becomes valuable is if you take your database abstraction layer and turn it into a read-through cache. And the way to do that would be by adding a caching component into the abstraction layer that offloads all of your result sets to a cached object store. Memcache is probably the most popular. That's what I've spent the most time working with, but there's others out there that can be used. In theory, you could use just about anything. I mean, in theory, you could literally write your results, serialize them, throw them into a text file on disk using something like ATime to see if it's expired. I wouldn't necessarily do it that way. I'm just pointing out that you could use almost anything. You could plug pretty much anything in here to do this. So one nice thing about caching through the abstraction layer is you can define TTLs, time to live, and have the developers that are writing each individual query basically pick, okay, when they're writing the query, they know how that query is going to be used. How long can the results live for? Is that a query that needs to be instant every time it's executed? We need the most up-to-date data. Maybe that's the case. Can it, in this case, that would be disabling caching. Can it inherit a default, right? We have kind of a global blanket that we want to say, all right, all of our queries, they're going to cache for this long. Or it can be specified for each individual query. Maybe there's a query that can be cached for 10 seconds. Here's a query that can cache for an hour. Here's another one that can cache for 2 hours. Depends on what it is. This could give the developer the flexibility to control the cache on each individual query. So memcache, since we're talking about memcache, basically stores key value pairs, right? The value in this case would be the result set, and the key would be the query. Now, I don't know if this has changed, but memcache, the maximum string length for a key in memcache was 255 characters. That may have grown. Your queries may be smaller than 255 characters, but why risk it? What I've always done is created a hash, so no matter how large your query is, it doesn't matter, it's not going to get truncated, you don't have to worry about multiple queries colliding with one another, executing a query and getting the wrong result set. So I've always used MD5s, they work pretty well. Now, one of the things that I think is really valuable is if you are going to do caching, take the abstraction layer, and if you're passing a TTL in, have the abstraction layer take whatever the TTL is, append it to the end of the query as a comment, and then funnel it to the database. Where this becomes really valuable is if you start having a problem with a query. You get a table that didn't have adequate indexing on it, gets too big, whatever the case may be. All of a sudden you start having a bottleneck problem with specific queries, they become slow, whatever the case may be. You now have a bigger picture. It's not just tuning the query anymore, it's also taking into consider the caching for that query. And I'll give you an example of where that comes in really handy and why I'm saying that increasing the TTL may actually be more efficient than tuning the query. If you've got a query that takes 10 seconds to run, but you only execute that query once every 2 hours, and you have another query that takes 10 milliseconds to run, but you execute that query 1,000 times per second, I'd rather have the query that takes 10 seconds to run and only runs every 2 hours. The way I look at it is the most efficient query is the one that never even gets executed. So again, even if you have a query that's a problem, you might tune it as far as you can, but then you might be able to say, well, we can't make this any better, so instead of this query caching every 60 seconds, maybe we could bump it up to 5 minutes or something like that. It just depends on what it is. But having that visibility on the database side becomes really extremely valuable. So let's just say that you like the idea of caching, and you have some kind of CMS system, and the administrative controls and the front-end presentation layer are actually both using the same database abstraction layer. So you may be thinking, well, this sounds great, I'd love to cache, but the problem is the administrators using these tools, we can't cache that stuff, right? They need, every time a query is executed for something they're doing, they need to make a home run to the database, they need to see the most up-to-date, most accurate data. If that's the case, put some kind of a hook in the abstraction layer. Again, this would be nothing more than literally like an if statement. The abstraction layer just looks before caching. As a prerequisite to caching, are we not an admin, so to speak? And it just depends on the application how you would check for that. It could be an environment variable. It could be something in a session. It could be a lot of different things. One of the ways I've actually done this is literally have the abstraction layer look for the word admin right in the query string. If it contains the word admin, no caching. Consider taking a larger query and splitting it into lots of smaller queries, or not lots of, but more smaller queries. One of the reasons why this would be valuable is because you're caching each individual query. You may not have to hit the database with all of these queries at the same time or with one big one. So we may have a query we may have a subquery. Instead of doing all that at once, break it into a few different pieces. Each of those can get cached independently so that whenever they have to get re-executed, they will expire independently of one another. Right? Now you may be thinking, well, if I define one TTL, let's say 5 minutes, they're all going to expire at the same time. Well, a colleague of mine had a great idea on how to handle this, and what he did is he came up with a way to basically pad the TTLs with a random number of seconds. So you can either pad or subtract depending upon the application, whichever way you need to go. And what that does is it makes sure that every query, if you say, all right, I want to cache for 5 minutes. Well, rather than just a hard 300 seconds, it may be 308 seconds or something like that. So one big query broken up into several small queries will all expire at different times. So the only time they all have to hit the database is the very first time they run. So I also came up with a concept that I called the late connections or lazy loading database connections. And I came up with this because a few years back, we got really good at offloading reads over to cache. And one day I fired up a general log on a MySQL slave, and I saw something that surprised me. I saw a ton of connections coming in, connections being opened and being closed, and they were never doing anything. And it didn't take me long to realize what it was. It was because when you're using a database abstraction layer, what's the very first thing you ever do? Connect to the database. And then when you're ready to query it, you execute a query, and that's it. But what happened was, the abstraction layer got so good at offloading all the queries to cache, it was opening and closing connections to the database, and it was never even using them. So that's why I came up with this concept of lazy loading your database connections and delaying the actual connection until you need it. Because when you think about it, there's a lot of overhead in doing that. There's a lot of overhead on the database side, creating a connection that you don't need. There's overhead on the application side. There's even network overhead, TCP connection that has to be created and torn down. There's just absolutely no reason to do it. So the idea of lazy loading a database connection, really what happens is in your application, you tell the abstraction layer, connect to a database. Here's the database, here's the DSN, whatever, connect. And what the database abstraction layer would do is lie to you. So you're asking for a database connection? Yeah, I got one. But in fact, it actually never connected at all. What it would do is it would wait until after the first query that could not be fulfilled by cache, then it would connect to the database. So another thing that we kind of noticed is a lot of queries, when you go to execute them, may not have a result set, right? You could have an application that's a calendar, and you want to look at a specific page or a specific day in the calendar. and there may not be any events. So maybe querying the database based on a set of parameters, and there are no results. Well, what was happening when we first started this is we were taking an empty result set, there was absolutely nothing there, and telling Memcached, hey, I want to cache this stuff. And then what was happening is when the database abstraction layer was trying to retrieve from cache, there's nothing there. So it would think, hey, there's no result. It would think we don't actually, it wouldn't think there's no result, it would think we don't have, this is a cached miss, and we have to go back to the database. So what would happen is, any queries that had no result set would basically be bypassing cache, and every single time there would be one executed, it's a home run back to the database. So I came up with the idea to cache empty result sets. And really the way that works is extremely simple. There's just something in the abstraction layer. When a result set comes back, takes a look, sees what's inside. If it's empty, it just swaps it out with a character. I've always used a hash mark. You can use anything. Shoves another character in there. This way when it gets pushed in the cache, it's not empty. And on the way back out, it sees, oh hey, there's a hash mark. That means one thing, empty result. Turn it back into an empty array and pass it back to the rest of the application. And I have a diagram to show that as well. So here is basically a design if we're trying to do some caching in the abstraction layer. And in the query method, the first thing we might want to do is say, hey, is this query cacheable? And the way I've always handled this is the main parameter that's always passed in to a query method is the query. So what you would want to do is add a second parameter, and that is a TTL. How long can this query be cached? How long can this query be cached for? So is this query cacheable? Let's just say that it's not, first of all. No, it's not cacheable. Now here's where the whole lazy loading and delayed connection part comes into play. No, it's not cacheable. We have to connect to the database. So let's check. Do we have a valid database connection? Do we have a valid resource? Are we actually connected? If we are, great, we execute it. If not, let's just connect to the database. We'll wait. Connect the database, execute the query, and then return. We're finished.
There was one step missing. You need to save the cache after you execute. If you execute the query, you want to save it to the cache, right?
No, not yet. Because is query cacheable? No. So we're saying this query is not cacheable. We're saying that the developer who wrote this query basically explicitly said, I do not want you to cache this query ever, right? Another example would be if it's DML. If you're running an insert statement, you're not going to try to cache it. So we want to check to make sure not only is it, we want to make sure that we can actually cache it, we're allowed to cache that query. Now, for where you were going with this, if we are allowed, first thing we want to do is, okay, is this query cacheable? Yes. Next thing we're going to do is create a hash key. Very, very simple. Like I said, that's nothing more than just creating an MD5 hash. And here's it's a hash, but it's also the cache key for that query. The next thing we're going to do is we're going to find out, hey, here's the cache key. Do I already have this cached? Because we don't want to hit the database if it's already cached. So, is the result cached? Really all that would be doing is going to look at memcached or any other cache object store that you have and trying to find out, hey, is it in there? Well, the action of going to check if it's there, you're actually going to bring it back. You're actually going to be bringing it back from cache anyway. So that's what this step is all the way on the right. Is result set cached? Yes, it is. So what we want to do is we want to retrieve that from the cache. We want to store that as a class property because if you're decoupling your query from your retrieval of result sets, you're going to need that as soon as you actually want to grab your result sets. Let's just say that it was not cached, right? The query is cacheable, it has a valid TTL on it, and we actually need to execute this query for the first time and then cache it. So, is result cached? No. Then here comes append to TTL as a comment, like I was mentioning before. This way, on the database side, that could become very valuable. Append to TTL as a comment, we get back right here where we were before. Do we have a valid database connection? Yes or no. If we don't have one, create one, and there we go. So this would be the query side of checking to find out if you already have your result cached. If not, execute it. If you do, you grab it and store it as a property. The other side of this is going to be to grab your results when you actually bring them back. So the way I've done this is by storing, again, we said when we retrieve the result sets from cache, we're going to store the results in a property of the class. So basically, we can look at it, and say, is there anything in that property? Is it empty? Does it contain a result? If it contains something, then we know the result is cached. Are results cached? If it is, we retrieve the results from that class property that I just mentioned. And then here comes that whole component that I mentioned as well about caching empty result sets. Is the result a pound? Again, you can use any character in here. I've just used pound signs. It doesn't really matter what it is. You can use a longer string if you want. Is the result a pound sign? If it's not, you know you have a complete result set. Pass it right back. The application has absolutely no idea that this was just fulfilled by cache. If it is a pound sign, you know, okay, this is actually an empty result set. We're going to take this, we're going to convert this back to an empty array and hand it back to the application, and it will think you just executed the query and there was no result. So if the result sets were not cached, we executed the query, but now we actually have to retrieve the results from the database. So we're going to retrieve the results from the database, again, check, hey, are these results cacheable? If they are not, then we just return the results and that's the end of it. If they are cacheable, there was a valid TTL at the end, this is something we want to shove in cache, then what we're going to do is first check to see, hey, is this result set empty? If it is, throw a hash mark in there. If it's not, write it directly in cache. So this would all happen completely transparent with the application and give you the ability to scale if your application has a lot of reads and you don't actually have to make a home run to the database for every single one of them. So a couple things to consider with caching like this. If you use a full timestamp in your queries, if you're going to try to do this and you're going to try to offload some of your queries over to something like memcache, if your queries contain a full timestamp that was generated by the application, hours, minutes, seconds, what you're actually doing is you're defeating the cache. Because every time that timestamp is generated, it's going to be incremented by a second. So you're actually creating more overhead by even trying to shove that in the cache in the first place. So the maximum useful lifetime of that cache will be 1 second. Now, if it's a query that's executed 100 times in a second, maybe it'll still be valuable for your app. You may want to try considering rounding the seconds or minutes down to some defined interval, whether it's a minute, 5 minutes, 20 minutes, an hour, whatever the case may be. This way you could make the timestamp match your TTL that you define. So if you have a TTL that's defined on a query, hey, I can cache this for up to an hour, and you have a complete timestamp that goes down to the seconds, you're not really going to get any benefit out of caching on that. Another thing that you can consider doing is removing the timestamp and use the MySQL now function. Because what that will do is it will make every single one of your queries identical, regardless of whether you execute it right now or tomorrow. So now you only have to worry about the TTL.
Or not necessarily if it's not like 1 day or something.
Exactly. Yep. Now, I put this note in here because if your application is receiving a very high volume of traffic, you should also probably consider throwing another layer of cache in front of it, setting up some sort of a reverse proxy, something like Squid or Varnish, to handle caching at the HTTP layer rather than try to do it on the database side. Again, it just totally depends on what the application is. So a couple of other things to talk about as far as logging and error handling goes. One of the things that I like to do is try to use the database abstraction layer for logging error data. It becomes extremely valuable for debugging. So one of the things that might be valuable is if you've inherited a legacy application, or it's a very large application, there's a lot of queries throughout the code. If you've got a problem with a query, and you see that query in the database, hey, this is a very slow query, we keep getting hit with it, you may not be able to trace that query back to where it's from. You may have absolutely no idea where it's coming from. But if you do something like grab the URL and append it to the query as a comment, that may become very useful information. It may not give you the file and line number, but it may help clue you in on where that query is coming from. Right? It comes from this component, or here's how you get to it. So now that will save you a lot of time trying to find it. Another thing that you may want to consider doing is if you have multiple slaves that are in a load balance pool, you may want to consider actually every time the database abstraction layer connects to a database slave, you may want to consider grabbing something like the hostname. This will become very valuable if you ever have intermittent issues. If you ever have somebody reporting, hey, there's a really weird thing going on with the app, it keeps flapping. There's an intermittent data problem, right? I load a page, and most of the time I see this, but every once in a while, something different shows up. To me, that says, okay, you probably have a replication problem that's intermittent. If you have this debugging data in your abstraction layer, if there are certain errors being thrown, you may be able to review that data and say, okay, well, hey, look, all these errors that we're having, they're always happening in the slave. Maybe we need to take a closer look at it. And of course, you don't have to limit that to just data about the host name, finding out what host name you're connecting to. There are lots of other statistics that would be valuable to a return as well. Another thing that you can do is actually check errors. So after every query executes, actually look at the error. What is the resulting error that comes back? And if there's no error, everything is good, just go about your business. If there is an error, that might be a good place to throw an exception. Grab all that data, grab all the debugging data, dump it all into the exception, and somewhere further up the stack in the application, hopefully there's something to catch that exception and log it somehow. So since you're going to be looking at error handling, it may be valuable to make your error handling a little smarter and actually look at the error that gets returned. So one place this may come in handy would be connection pooling. So if you have a connection pool, you've got all these connections that you're maintaining open to the database all the time. It becomes a little trickier to pull a machine out of the pool than it would be if they're normally load balanced, and every time you connect, you're connecting to the load balancer and opening up a brand new connection. So what might have to happen is if you're doing connection pooling, you might have to forcefully yank one of those connections out. But what could happen is, by yanking it out, you could have a process running that was connected to that database server, its connection was severed, now its query is going to fail, and now you could start getting application errors because of it. So if that's a situation that you ever have, you may want to consider putting a little logic into the abstraction layer, so if the connection fails, whatever that error code is, it has the ability to reconnect probably up to one time. You wouldn't want that doing it indefinitely. You can also take the same approach of logging, right? If you have very specific errors that show up every once in a while, log them. Realize those errors happen, grab detail on it, and throw it to a log, but continue normally. Another thing that comes in pretty handy too would be the equivalent of an application level general log. If you've got multiple applications all hitting the same database server, then if you wanted to get a good, clear view of all the queries and all the SQL statements, all the activity that's happening, firing up the general log on MySQL may not be the best place to go because there's going to be a lot of noise. There's a lot of other activity, there's other applications that are connecting, other things that are happening. If you do some logging in the abstraction layer, again, you could do it with the query method, there's a lot of things that you can do. You could actually record everything that's being sent to the database and just dump it into a log file. I wouldn't suggest doing this in production, but this could be very valuable, say in a development environment, you've got lots of different applications, they're all connecting to the same database server, but you want to see what's going on, you want to filter out the noise, throw some logic in there to start writing all that stuff down into a log file. You can also log queries that are bypassing caching. So we talked about your query method, you would pass through the SQL statement, and you could pass through a TTL. The way I have done this in the past is basically there's 3 different types of values you can pass for a TTL. You can pass through false, which explicitly means never cache. You can pass through a true, which means, hey, I don't really care how long this cache is for, just pick the default. Or you can put an explicit cache TTL, 5 minutes, 300 seconds, whatever it is. Now, if there are queries that are passing through and they're explicitly bypassing caching with false, you may be curious, want to know what they are. So again, you could put a little bit of logic in the abstraction layer and say, hey, you don't want to bypass, you don't want to reject these, but maybe you want to gain some info on that. Every time one of these passes through, take that query, write it to a log file, so you can take a look at it later and say, hey, here's all the queries that are bypassing caching. Maybe we could take another look at these and actually start caching them. A couple of other things too. that would be valuable in an abstraction layer. And I've done this before where before and after your query execution, you grab a timestamp, including microtime. And where this becomes valuable as well is if you're going to throw an exception based on an error that happened, knowing exactly how long that query took to execute may become extremely valuable. And basically, all that would do is you have your query method. Before you actually send your real query to the database, not caching, but to the database, grab a timestamp, grab one after, you do the math, you figure out how long it took to execute, and then if you have to throw an exception, now you have all that data to throw in there, which can help you debug it later. Speaking of debugging data, another thing that I found very valuable is not just throwing the SQL statement that caused the error into an exception, but also the statement before it. You could have a statement, you could have a query that was sent to the database, and it returned a massive result set. And the result set was really big, and the application now had a lot of processing to do. Let's say that for every one of those records that gets returned, it's got a lot of work. As a result, that database connection is sitting idling. It's not doing anything. If you have small, very low wait timeouts, your database connection may actually time out while the application is processing all this data, and then when you go back to send your next query over the pipe and execute that, it may fail. In this case, it would actually be very valuable not just to know the query that failed, but to know the query before it. So a lot of different things that you can grab, capture, error handling, very, very valuable. Just mentioned the queries that disable and bypass caching. And I also mentioned the timestamp. So kind of to wrap up here, again, all these concepts, these are portable. You can use these in other languages, other databases. Database abstraction layers, they don't have to be heavy. They can be very lightweight, like the example that I showed before where it was literally nothing more than extending the basic MySQL I class. That's it. Gives you flexibility to add more later if you need to. One, I guess you could say, misconception is often, in terms of pros and cons, is often a con of database abstraction layers. People often argue they decrease performance, right? There's a lot of overhead, a lot of extra work they have to do, but when you start plugging in things like caching, abstraction layers will actually drastically increase your performance. Think about all the extra workload that your database servers would have to do if you couldn't cache all those queries, if you're using the caching part of it. Same thing, if you're trying to split your reads and writes, it's going to boost your performance because if you send all that stuff up to your master, it's going to bog it down. The examples that I showed are basically extending MySQL, like I said. But you don't have to do that. You don't have to extend it. You can write a brand new class, you can write all your own new methods. Like I said, you don't have to overload. You can create something totally new. You can map all your methods. I've seen abstraction layers where people couple query execution and retrieval of result sets together. It's kind of personal preference, however you like to do it. Really the point is, more than anything, having a central conduit where all of your database activity passes through gives you tremendous flexibility in many different situations. The stuff that I've mentioned, most of these I've actually used in production in one way or the other. I'm sure there are countless other ways that a database abstraction layer could be used and would be very, extremely valuable. And that's pretty much it. I kind of threw a lot of things out there. Questions? Thoughts?
Yeah, I have a question right away. So you guys using like a lot of stuff in production. Are you using any like off-the-shelf abstraction layers? We have some kind of homegrown stuff? Or?
We use a couple. One of them was custom and we written in-house. The other one was one of the ones that's available, and we heavily modified it to do some of the things that I mentioned, like sending your selects off to someplace else. I'll give you an example of one of the things that we've used it for. We have several different components, legacy components, and they all had their own separate abstraction layer. There might have been like 10 of them. Well, the problem with these is, for whatever reason, when these things were built many years ago, they all kind of did the same thing. In no exaggeration, the only thing that differed between some of these abstraction layers was the interface. One of them might be camel case, one of them might be underscores, that's it. So they also sent a lot of select statements up to the master, was a big problem. So one of the ways we tried to address it was by creating a new abstraction layer that would be backwards compatible with all of the old ones and just kind of dropping it in place. So rather than having to go back to all these legacy application components and rewrite.
Just putting like facade on top of it.
Exactly. It just picks it up and it gives us the performance boost without us having to do a lot of extra work.
And the second question, I see you, in your examples, you extend the specific databases, like extend MySQL. Are you guys using the PDOs in any ways, or what does it take?
We use, I have not done a lot of work with MySQL. I literally just started playing with it recently. I don't do a lot of development much more these days, so I've fallen a little bit behind on that side. One of our most robust database abstraction layers that I would say that I wrote several years ago, that's doing a lot of the stuff that we talked about. It's not really doing things like splitting reads and writes, it's doing a lot of stuff like caching, the delayed connections, all that kinds of stuff. And we take on the number of queries per second changes from time to time, but on any given day, I would say the number of queries per second that we have gotten recently to some of our slave databases is probably in the order of about 10,000 per second. And that's not including cache.
So that is built on top of the specific database, like driver, not a PDO.
That's actually probably using the older MySQL connection libraries.
Thank you.
Mm-hmm.
So you're more of a database guy than a developer, right?
These days.
These days.
But I've done, if you look over time, I've spent more time on the development side than I have on the database side over the years.
Okay, have you played with Doctrine?
I have not. I've heard of it, but I haven't looked at it.
All right, I was going to ask you your thoughts, but if you haven't played, so never mind.
Yeah, that's what I mentioned. There are so many of these now. I haven't kept up with all the different ones that are out there.
Yeah, it just seems Doctrine is like the de facto one that everybody's talking about on the PHP side. Personally, didn't really like it, but
Oh yeah?
a lot of people do. Any other questions from the audience? Yes.
I see you looking like you have a question.
No,
You're thinking about it.
That was my question. I was going to ask about document.
So you have your answer. All right.
I can add a little bit. So in PHP itself, I feel like using if you're building your database abstraction layer, there is one that comes with PHP. It's called PDO, it's PHP database object. And the good thing about that one is that it's actually written in C, so it's very fast. Unlike everything that you write in PHP on top of it. But there are a lot of abstraction layers that people build. They build on top of the PDO because it gives you kind of standard interface towards all different database drivers that you may connect. You can connect to MySQL, you can connect to Postgres, you can connect to Oracle if you want. There's always peculiarities specific to particular database engine, but there's a lot of common functionalities on top of it.
Yeah, absolutely. You could use, you could write your own on top of that, and that can connect to both MySQL and Postgres, for example, and it could still handle all the caching.
Yeah, and if we speak about Doctrine, it's Doctrine itself is not as necessarily as abstraction layer. It's actually the ORM engine, which is a little bit it is kind of a little bit more monstrous beast than just a general database abstraction layer, because it includes a lot more functionality than the normal abstraction layer would be.
And that's one of the
abstracts away the SQL statement, so you don't know what the hell is going on.
Yeah, it abstracts a lot of object manipulation for you, and it relies a lot on different naming conventions within the database. So it actually constructs a lot of SQL behind the scene for you. It helps in one circumstances. It kind of beats you in the others. Very often you kind of fight with the entire engine just to make it do what you want, what the thing wants to do. And the thing is, there is too much black magic happening behind the scene that sometimes it's very difficult to fine tune your application. It helps you though to build, if you need to prototype something really quick, it definitely helps.
Yeah, and sooner or later you'll find it'll do a query in a loop, and then you just want to shoot yourself in the head. Anyway, thank you very much, Peter.
Thanks.